Today we're going to be talking a little bit about line plots and dot plots. So what I'd like you to do is in your notebook, I want you to go ahead and copy down our learning target for today, which is I can use line plots to make conclusions about data. And then the title of today's page is line or dot plots, because we are going to talk about the difference between those two. And something called data distribution, which is just a fancy way to say how the data is spread out. So before we start, I want us to talk a little bit about a line plot or a dot plot. So a line or a dot plot, you should have had these in elementary school, but a line or a dot plot is just a graph that shows the frequency, and that is a fancy word that we have been working on through this unit. Frequency means how often something happens, of events plotted on a number line. And I'm abbreviating. If you want to write out the word number, go for it. So in elementary school, you probably saw line plots and dot plots quite a bit. And we're just going to kind of sketch some in our notebook. So if you'll sketch one here, this one's going to be a line plot. And then on this side, we're going to do a dot plot. So the line plot is going to be the number of dogs. So let's say that I asked the people in my classroom, how many dogs do you have? And maybe we had some answers that were in this range. So if you'll label that. And let's say that one person said they don't have any dogs. Well, that means I put an X above the 0. And then maybe 3 people said they have 1 dog. So I put 3 X's above the 1. And let's say that 2 people said that they had 2 dogs. So I'll put 2 X's there. And then one person said they had 4 dogs. And one person said they had 5 dogs. So I want to draw your attention to a couple of things. First of all, notice that all of my X's are the same size. That is very important because if you don't do that, then your data doesn't visually look the way it should. The second thing that I want you to notice is that even though there's no data right here in this range that I'm circling in pink, we still have it on our number line. And that's because it's in our range of data. So if we left out this 3 and our graph just went 0, 1, 2, 4, and 5, then the way that the graph looked would be completely different. And that is important as we begin to talk about how data is distributed in our graph. Let's switch gears and do the dot plot. The dot plot is very similar. Let's say that the dot plot is going to be the number of days. And let's say this is the number of days that students were absent. So this one's going to go from 0 to 5. And let's say that there was one person who didn't miss any days. So you'll notice that the major difference is that instead of using X's, we're using dots. It's still on a number line, and we're still only representing one person with each dot. Now you do have to be careful. Sometimes each X or each dot might represent a different amount, but they'll have to give you a key to show you that. Let's say that there were 4 people who missed 1 day, so we're going to put 4 dots there. There were 3 people who missed 2 days, 1 person who missed 3 days, 2 people who missed 4 days, and 3 people who missed 5 days. So this would be our dot plot for the number of days absent. So what we're going to do for just a few minutes is we are going to attempt to build our own line or dot plot. I'm going to allow you to choose. So you're going to need a copy of a piece of paper that looks something like this. And what you're going to do is you're going to glue it into your notebook so you see where I'm going to put mine. And then it says that the data shows the amount of time in hours that students in a high school course spent studying for a recent test. So every time you see a number, that represents the number of hours that one student studied for a test. So this says that there was one student who studied 2 hours. This means there was one student who studied 0 hours. We all know that happens. This student studied 4 hours. This student studied 1 hour. The instructions say first organize the data into a frequency chart. So we have built frequency charts before. We started that earlier last week. So what we're going to do is we're going to make a frequency chart. Your frequency chart needs to look something like this. The first column is going to be the hours that the people spent studying. The next section is going to be our tally section. Now remember, frequency charts won't always have a tally column, but today we are going to build a tally column. And then this last one is, of course, the frequency. So when I look at my numbers, obviously the first number is going to be 0. And then the next number is going to be 1. And then the next number is going to be 2. And then I have a 3. And then I have a 4. I have a 5. I don't have any 6s. I don't have any 7s. I don't have any 8s, but then I have a 9. So this looks like the setup for my frequency chart. So what I'd like you to do for just a second is pause the video, and I want you to take just a few minutes and go through your data, and I want you to fill in the tallies. And I skipped number 6. I can't even count. We'll put number 6 down here just for good measure. Fill in your tallies, and let's see what you get. So pause the video, and let's see if yours matches mine. Okay, so now that you're back and you've paused the video, this is what I ended up doing. So when I see this, I see I have 0, I have a 2, a 4, a 5, a 1, another 1, a 2, a 3, a 4, a 3, a 9, a 0, 1, a 3, 4, 5, 1, another 1, so tally mark across, a 0, a 3, a 2, and a 3. So this is my data. Now notice I don't have anything here, so I'm going to go ahead and put zeros here. And then the frequency that I get is 3 zeros, 5 1s, 3 2s, 5 3s, 3 of those 4s, 2 5s, and there's only 1 9. So now that I've done this, we're going to build a dot or a line plot, and you can choose. In my notebook, I am going to do a line plot. So we start by drawing a straight line. And we're going to start at 0. And I'm going to go to 10, just for good measure, because I know that my numbers go 0 to 9, but I like to make mine look correct. Now, I kind of got off just a little bit right here, but I do want you to notice that I tried to space all of mine evenly, and that is important. You want to make sure that your numbers are spaced as evenly as possible, because if not, then of course your graph will look different. So then we're going to plot our data. This represents the number of hours spent studying. So as with any graph, a bar graph or a line graph, you want to make sure you have labels. And then I'm doing a line plot, so I'm going to do X's, but if you want to do a dot plot, then you can do a dot plot, that's fine. So we're going to do 3 X's above the 0, 5 X's above the 1, 3 X's above the 2, 5 X's above the 3, 3 X's above the 4, 2 X's above the 5. There were no 6s, no 7s, no 8s, and then only 1 above the 9, and then I have nothing over the 10. Now, I asked you to do this for a very, very specific reason, and that's because we're going to talk about some things that you have to know about today. When we're looking at the way that the data looks, that's called the distribution, how it's spread out from start to finish in our graph. And there are some things that I want to draw your attention to today. The first thing that I want you to notice is that right here on this side of our graph, we have all of these X's or dots, if you made a dot plot, that are seen to be grouped together. This is called a cluster of data. So a cluster of data is a group of tightly grouped data. So what you notice inside that pink box is that we have a lot of X's on this particular side of our graph. The next thing I want to draw your attention to is that right here in the center, we have an area where there's nothing. And this area where there is nothing is called a gap. And just like a gap between two mountains or a gap in the curtains, a gap is an area where no data appears. So what you notice is it's almost like we have a hole there. And then the last thing that I want to draw your attention to is this one lonely number out here by himself. And if you notice, this number seems to kind of be the odd man out almost. He doesn't really fit with the rest of our data that was clustered over here. You typically know that you have something going on when you have one large gap in a graph and then you have one or two pieces of data that don't seem to fit with the rest of the group. These have a very special name as well, and these are called outliers. O-U-T-L-I-E-R. An outlier is a piece of data that doesn't resemble the rest. And there's actually a mathematical formula that you can use to determine if a number is an outlier or not, but we're not going to get into that today. You can basically spot an outlier if it seems to not really fit with the rest of your data. So those are some important parts of data distribution that you have to know about. The next thing that we're going to do is we're going to stop the video and you're going to go back to your Haiku page and you're going to answer a question based on your favorite color of jelly bean. I would like you to limit them to just basic colors: red, orange, yellow, green. I guess you could do blue if you wanted. So basic colors of jelly beans. And when you're finished, you are going to create a line or dot plot in your notebook based on your data. When you are finished with that, I want you to do, if you did a line plot here, I want you to do a dot plot. If you did a dot plot here, I want you to do a line plot with your jelly bean data. And when you're finished with that, you will put that here in this space. And then whenever you're finished with that, I want you to play the next series of videos and we'll talk a little bit about what do you answer based on those graphs that you've created.